So welcome students, welcome to the today's class of software engineering. Students, is my voice audible? Students, is my voice audible? Please any of you respond to me.
Yes, madam.
Okay. So welcome to the today's class of software engineering. In the yesterday's class, we were seeing unique nature of web apps. This is what we saw in the yesterday's class. So what is a web application? We told that any client server program which the client is going to run by using a browser comes under web application. You see different web applications, you use different web applications every day. So what make the web applications unique when compared to the normal desktop applications? That is what we saw yesterday. I'll say that web application is unique because it is having all these following features. Because one of the feature is network intensiveness. What we told is because the application is residing on the network, it is present on the network, so any person across the world can use that. That is what we told here. And next one is the concurrency. In the sense, large number of people are able to use that web app at a single time, right? And next one is unpredictable load. The number of users or the count of the users that are accessing the web application is never considered. How much of load, how much is applied on the application at the same time, it will work at the same speed for all the people around. Next, we saw the performance issue. What we told here is everything is displayed within fraction of seconds for you. It does not make you wait before the system for time, right? Everything is displayed within at the earliest, right? And next is the availability. What we generally feel is we want the application to be accessible most of the times, any of the time, not most of the time, at any fraction of second. So that is what is done with many of the web applications. Mostly all the applications on the web will be accessed at any time in a second. And next is data driven. As you see, all the websites you will be using will be having some text included in them, will be having some graphics, some audio running around, some videos playing, some ads playing, all these things. So in your web page, all the contents is all this content is data is embedded in that website. So that is the feature called data driven. And next is content sensitive. What we told here is the quality of the websites, the look and feel or the beautiful looking of the websites always makes us attracted. So that is the feature called content sensitive. And next we saw continuous evolution. Most of the web applications will be evolved continuously, in the sense that new features will be added into that application most of the times. That is what we call continuous evolution. And next is security. All the web apps provide you the basic security features. Only the authorized users will be able to will be able to access that application. For example, your Gmail will be protected. You will be protecting your mail or Facebook, everything by using a password, right? So that is a security feature. And next one is the aesthetics. Nothing but the look and feel nature. The which makes us attracted. The maybe the colors we are using, the animations that are going on in that website, or all these things make us feel to use that website, right? That is the thing we saw in yesterday's class. And coming to our today's class, today we'll be seeing just a small definition before going in detail into the software engineering. These are the some basic definitions you need to know about this subject. The first thing is legacy software. Now, you know what is a software. You already told that software is a group of instructions which are used to perform some, meet a particular goal, used to perform some task. Then what is legacy software? What does this legacy mean here is, a legacy software can be defined as an older software which is already developed in the past, in the sense that all the softwares that are developed some decades ago, some years ago, previous developed Chesina softwares, whatever are there, all those are will be called as legacy softwares, right? There is a common saying for all of us, like old is gold, right? Old things is always a gold thing. Gold. We don't throw away the old things. Why? Because they will be helpful for us. They'll give us the best when compared to the modern things also in some cases, right? So same thing in the case of legacy softwares, right? Older softwares, there are different authors who gave their views about these older softwares, previously developed softwares. So there is an author called Ford and his colleagues. They gave the statement of legacy software in the following way. So what they were saying is, they are saying that the legacy softwares were developed decades ago. As I already told you, they are already developed in the past, some years ago. Old and oldly developed softwares. They developed some decades ago and have been continuously modified to meet the changes in the business requirements. These older softwares which are being developed in order to meet the current day business needs or current requirements, what those older softwares need to do is, we need to keep on changing them continuously so that they will be suitable for the present business requirements, right? So they are saying that these are developed decades ago and these have been continuously modified to meet the changes in the business requirements and computing platforms. Maybe the platform that is run that older software were designed to run on some different platform, and nowadays you are using different platforms. So you'll be changing that software, features of the software, so that it will be able to run in the present day platforms also, right? So, and what they continue is, they say that these softwares are causing headaches for larger organizations who find them costly to maintain and risky to evolve. See, these the maintenance will be very high for coming when coming to this legacy softwares. Right? That is the problem most of the organizations are facing. It will be very costly to maintain all those. In the sense, we can develop new things easily, but if we want to make the older one apted for a new one, then it takes much time, right? It makes us more costly. Also, we need to face many risks while doing so. So that is what they are saying here. Many of the organizations are facing many headaches in maintaining this softwares, right? But there are different authors. This is the perspective of these authors, Ford and his colleagues. These authors had following perspective about legacy software. But there is another author who is called Lee, who describes that these legacy softwares, even though they are difficult to maintain, but these legacy systems remain supportive to core business functions and are indispensable to the business. What they mean to say is, even though it is very difficult to maintain and costly to maintain all these older softwares, but they are very supportive to the present business functions till now, present business need till date, right? And it is risky to erase all those older softwares and replace them with all the new softwares. In some applications, it will be very risky if you remove all the older things and start everything newly from the beginning, right? But suppose if you take any airline applications, Air Force applications, Air Force application where the pilot will be given instruction where to land, where to, what will be the temperature, everything. In that application, they'll be using some older softwares which we has been was developed some decades ago. The same software will be continued till now with slighter modification. That is the thing generally goes on. But if at all they think to remove all the older software at a time and start replacing it with a new thing this day, then what generally happens is, we don't know how far this new software will be successful, right? We need to have some trials first, or else everything, there'll be a lot of damage in damage in the form of resources or damage in the form of human everything. If a new software is installed into an aeroplane and just ask them to go by using will manage everything, then we don't know how far that is going to be success. So in that areas we can't take risk of replacing the old one completely with the new one, right? So that is what these authors are saying. So some authors are saying that legacy software, it is very difficult to maintain all those things for many organizations, whereas some other authors are always supporting legacy software, saying that even though it is difficult to maintain and risky to maintain, it is going to meet many of the current trending business functions. So it should be maintained. Why? Because we can't replace everything. It will be more risky when replacing everything by a newer things, right? So that is what many of the authors are saying. And coming to this legacy software, they should be changed to some extent. Why should the legacy softwares be changed? Why? Because the legacy software should be changed such that they should be adapted to meet the needs of new computing environments or new technologies. See, right, the older software, maybe one software we have developed which runs in Windows XP, and now that you want that software to be run in Windows 10, in Windows 10 platform. In that case, that some changes need to be made in that older software, and the older software should be in a stage. It should be in a stage to adapt all those changes, right? So that is what we are saying. These older software should be adapted to meet should be able to adapt the changes right here to meet the needs of new computing environments or new technologies, right? Even the technology keeps on changing. Maybe take in the case of programming. Now that you have learned your C programming in first year, right? But you will not be using C programming for coding when you go to your industry. Maybe you will be using some trending language, which is presently some trending languages, some Python. Maybe you will be using Python for coding there, right? So the older software should be able to adapt new changes so that new things can be embedded into that one, right? So that is what we are saying. And next one is the software must be enhanced to implement new business requirements. It should be able to integrate new business requirements into that one. That is what we are saying here. And next one is software must be extended to make it interoperable with other more modern systems or databases. So what we are saying here is it should be interoperable. It should be for suppose if you write a one program in your, if you develop one application, if that application is going to be run in your house, in your operating system, if the same application should be able to run in some other operating system or some other platform in your friend's desktop also, right? So you can't just develop applications only for your single purpose, right? Any application you develop will be used by different people around the world. Different people will be using different resources, different platforms, different environments, everything. So any application you are developing should be able to run in all different types of platforms. So that is what we are calling as interoperable, right? And next one is the software must be re-architectured to make it viable within a network environment. The worst case, if required, maybe the software should also be re-architectured. Maybe the complete design should be changed. Complete design of the software should be changed to meet for the current network environment, right? Maybe to meet the current web services or anything. The older services may not be suitable for the current web services. In that case, the software should be completely re-architectured, right? So that is what we are saying, re-architectured in the sense. So anyway, what we finally want to say here is the legacy software should be able to include some changes within it so that it will be suitable for current business needs. See, take an example of remodeling a house and rebuilding a house. For suppose you're having a house already, you want to make it look beautiful according to the current trending things, right? Then what you do is you remodel the house. You just don't rebuild the house. In remodeling, what we do is in the older house, we try to change something, some lookings or some walls or something, so that it will look like a new thing. So same thing happens in the case of legacy softwares also. All those older softwares, there will be some new features will be added into those older software so that the current business needs will be met by them. So this is about legacy software. And coming to the next one is software engineering realities. From here we need to start software engineering. Till now just we saw the basics about before going into software engineering. So what we saw is what is a software, what are the characteristics of software, what are the different types of softwares, different applications of softwares. And next we try to identify which is the most unique application. We told that web application is most unique. Why? Because it is having some features. That is what we saw. And finally we gave a small definition for legacy software. And from here we need to start our software engineering. Actually we need to start the definition for software engineering. I already gave you the IEEE definition for software engineering. If you remember, this is what the IEEE definition for software engineering we gave you. We told that software engineering is nothing but developing your software using some engineering principles. When going in detail, what we told that it is application of systematic, discipline, and quantifiable approach. So what we are saying is you are developing your application, you are developing your software by using some systematic, some structured way, some disciplined way, some fixed plan, or some repeatable plan, or something like that way. And next, quantifiable approach means you should be finally able to measure whether the product is of quality product or not just meeting the solution, not just coming out with the solution. The solution should be the quality one, it should be the best one, right? So you're performing all these to develop, operate, and maintenance of the software. So right, this is what we saw the definition for software engineering. And from here we need to start our software engineering. Before starting our software engineering subject in detail, let us see some basic realities you need to keep in mind while developing a software. In software engineering, what we do is we engineer, we perform, develop software, right? While developing software, you need to keep some realities in your mind. So what are all the realities you need to keep in your mind? A concerned effort should be made to understand the problem before a software solution is developed. First of all, before going into software development, most of you, not most of you, all of you are future software engineers. All the 12 people or 11 people who have joined in the class today is future IT professionals. All of you will definitely have a software engineer job in future, right? So what you will be doing in your job is you will be developing your softwares, right? You will try to find the solutions for your given problem. So while developing a solution, the first thing you need to understand is, first of all, you need to understand your problem. Unless and until you understand what the question is, you'll not be able to write anything in your answer paper, right? In your exams, first of all, you need to understand the question, what is asked in the question paper. Then only you'll be writing some solution in your way, right? So same thing, when you are asked to solve a problem, you try, before going into developing the solution part, first of all you need to understand the problem in detail. Why? Because who is going to give us the problem? A normal client is going to give us a problem. That client may not be a technical person, right? He's a normal person. For suppose some person came to me and he's asking me to develop a application for his supermarket, right? That person is a normal technical person. He's a business person. He don't have any technical knowledge, but he want to automate all his things in the supermarket. So he want me to develop some software. What he will be saying me, he'll just ask me to write some supermarket application. He'll not be able to tell me what modules he want in details, or he'll not be able to tell me you use this technology to develop this software, you use this platform, maybe that should be secured, or that should look good for me. He'll not be able to tell all these things, right? Why? Because even he don't have the knowledge of all these things. So what we say here is, the problem is given by a non-technical person in some cases. For you to develop, first of all you need to understand the clear problem statement, then only you start developing a solution. Even in the industry, no one is coming and giving you the spoon feeding kind of thing, right? They'll just give you the problem statement and ask you to develop. It's your risk, your task to do all the things, but no one is coming and asking you to develop this, write this lines of code now, right? Develop this module now, do that, do this, right? Everything should be done by your own. So in order to do so, first of all, you need to understand your problem. That's what we are saying here. And the next one is the design becomes a pivotal activity. The success of the software product mainly depends upon the design, right? uh, Finally you'll get a solution for your software, for your problem. Definitely you'll try to find some sort of solution for your problem, but how you'll get a successful solution? If at all your design is of a good one, your model is of good one. Why? Because I already told you in the first class of software engineering, we'll follow different phases for developing the software, right? These phases include, first one is you communicate with your client what he wants. You communicate and take all the requirements from the client. And next one is you start planning, you start designing, right? Planning and designing. In designing you will be creating developing the models or diagrams, in your sense your flow charts, right? You'll develop the models. What will be the system architecture look like? What will be the modular architecture? What will be the, all these diagrams will be prepared there, models will be prepared there. And then you go for coding and testing and next deployment. All these things come next stage, which we'll be learning in our next classes, right? So finally, if my product should be a good one, if at all my design is of good one, my model is of good one, only then only my product will be of good one. Take the case of a civil engineer. He is going to construct a large project, large buildings. The success of that building ratio always depends upon the plan he is designing initially, right? If his plan is good, his plan is correct, then his product, finally the building will be of a good good thing, right? And next reality we need to keep in mind is the high quality, right? Finally, the main goal of any software engineer should be to develop a quality product. See, there'll be different ways to solve a problem. For suppose I need to travel from here to Hyderabad, there are different ways for me to travel. My problem is I need to travel from here to Hyderabad. The solutions are, there are different ways to travel. One solution is I can go by roadways, I can go by airways, I can go by railways, anything. There are different solution. But which one I'll be choosing? Whichever is the best for me, right? In the same case, when you come to software also, in software development, different softwares will be developed meeting the same need, meeting the same purpose. But which among them will be selector, or which among them will be best? Only the quality one, only the thing which is having a high quality. Quality, in the sense, quality is measured by different features like reliability, security, maintenance, all these kinds of things, which we'll be seeing later in the later chapters. Quality is not like a hardware kind of thing which you can touch and feel it for software, right? You can't touch and feel the quality of the software. So this is a complete different thing which we'll be seeing later. So this is what we need to keep in mind while developing any software. See, I'll go, if I suppose I want to purchase a fan, I'll go to a supermarket. I don't have any idea about which company of fan which will be the best one. What I'll say, I'll be having different fans displayed over there. I'll look, first of all, I'll see which is beautiful, which is not the major issue to be considered. Next thing, what I'll notice is I'll see one fan which is having some ISO mark over it, and the other fan which is not having any standards, any ISO marks or such kind of thing. Then definitely, even though I don't have any technical knowledge about fan, I'll go for ISO mark fan. Why? Because it is resembling that, it is saying me that this fan is of some quality. It is developed by using some good quality standards. That mark is indicating me there, right? So then definitely I'll go for that one. So that is the thing, what generally happens if you have a quality product, right? And the last one is software should be maintainable. Generally what the software engineers think is that if at all only coding is done, I'll just code my project, I'll find the solution, I'll just write the programming part and leave it. This is not the thing. When coming to industry, there are many things that are involved in performing in job, which one among is the maintainable part. Even though you develop your software and deploy it to the client, if you give it to the client, after some couple of years, you need to maintain that software. Why? Because you are the person who have developed that software, right? You'll know the flaws in it, you'll know the truths in it, everything. So you will be the person who will need to maintain that software some years. Take an example of any hardware device you bring, or for suppose I bring an AC to a house, I bring a washing machine to a house, I'll be having a warranty guarantee period for 1 year or so, like that. So what is that warranty guarantee period? So it's a period where the company is going to give me some maintenance, right? For suppose within that period, if any component fails in that machine, or if anything need to be replaced, the company will come to me, and it's their duty to make the changes, or it's their duty to replace, or it's their duty to do the necessary things, right? So that is a maintenance period for that component. So same in the case of software also, you'll be having some maintenance period. In this maintenance period, what generally happens is, maybe the client will be coming to you and asking you to do some changes. Maintenance in the sense, not like replacing the components in the case like in hardware. In our software, mostly maintenance in the sense, once you give the product to the client, he'll be using in the real life environment. When he's using, he'll be having new ideas generated. Maybe he'll think like, this web page is not looking good for me, I'll ask the manager to change. Again he'll come to you and say that, I didn't like this interfacing, it is very difficult for me to click all this, make it easy for me, or do these necessary changes for me. So all this comes under maintenance, right? You need to satisfy the client to some period of time by doing all the changes whatever is necessary in that, right? So this comes under maintenance phase. So these are the things we need to keep in mind before going into the software engineering subject. So students, in today's class, we have just seen some one basic definition of legacy software. We roughly told that legacy software is the older software developed in the past. And before going into the software engineering, we need to consider some realities. The realities would be, first thing is, you need to understand the problem before starting the solution. Second one is, your design should be a good one that plays a major role in the successful of your product. And next one is software that should be of high quality. And the last one is, the software should be maintainable for some period of time. These are the things you need to keep in mind while studying the software engineering subject. So any of you are having any questions? So students, any of you are having any questions?